Happy Monday. Hope you enjoyed your weekend. Today we are going to continue talking about exponential growth and decay, but we're going to talk about some specific ones this week, starting with one called doubling time. So I'm going to give you kind of an example. Maybe you've seen this in a science class where we talk about cell division. So let's say we've got one single-celled organism, and at a certain point in time, it will split into two, doubling its quantity. And then after the same certain amount of time, each of those individuals will also split, doubling themselves again. And then each of these will split every time, doubling the size. And again, if we went through and did this, obviously it would take forever sometimes to do, and this would get really annoying. So we need a better way. And again, if I went through and counted, you could see that there was 1, then it doubled to 2, then doubled to 4, then doubled to 8, then doubled to 16. And again, this is a form of exponential growth called doubling. And this is very common, especially with organisms, the way they work. All right, so let's try the formula. Excuse me. So again, this is a formula that we'll use instead of doing that giant tree diagram I just showed you. So P, it's our population, equals P sub 0, which is the initial population. That sub 0 usually stands for initial or starting amount. And then it's doubling time, so that's where that 2 comes from, for being doubled. And then we have the T, and that's the amount of time we're looking at. And then D is how long it takes for the item to actually double. Does it double every 3 hours, every 3 days, every 3 months? So we need to know how long it takes for that population to double in size, and how long we're actually looking at in our specific example. So let's try some. It says, the number of rabbits in a certain population doubles every 40 days. Now, it says certain population. That's important detail to know, because that means different populations in different areas of the world, the rabbits are going to double at different rates. It all depends on their environment. Again, if the rabbits are at the North Pole, I doubt that their rate doubles very quickly because they're going to all freeze to death. But if they're in a place where they can grow and expand without predators, like when the Europeans introduced rabbits to Australia, and they bred like rabbits, and they didn't have any natural predators, so there was nothing eating the rabbits to make their numbers go down, so their numbers skyrocketed. This is called invasive species. We're definitely going to be doing some more work with invasive species coming up after winter break. Do a little project related to that topic. So anyway, let's get back to this. So the rabbit population doubles every 40 days in this particular area. If the population, again in this area, starts with 12 rabbits, what will the population be 160 days from now? All right, so let's set up this formula. Again, the formula looks like this. P equals P sub 0, it's doubling, and then T divided by D. All right, so let's fill in the numbers. We don't know what the population is going to be, but we know what it starts with. We know the P sub 0 number. We know that that is 12. Started with 12 rabbits. All right, we're going to have this 2 that's always there. And now our little exponent, T over D. Well, T is how much time. So we're measuring everything, seems to be measuring in days. So the days would be 160 days. Divided by D. How long does it take for the population to double? And it said back here it doubled every 40 days. All right, so let's simplify that a little bit. That's 12 times 2, and then 160 divided by 40 turns out to just be 4. And if I did that, I would end up with 640. But it's a word problem, so we need to answer it with not just numbers, but words. So that means in 160 days, there will be 640 Whoa. Think about that for a second. 160 days, that's less than half a year. So in about 5 or 6 months, we're going to go from having 12 rabbits to 640 rabbits. If, again, they are allowed to double their population without anything getting rid of the population. And we're going to talk about, again, this later on at the end of the week when we talk about actual population growth and how it works. But again, this is the whole idea of invasive species. If we have a species that comes into a new area and they are growing faster than they are dying. They're multiplying quicker than they're having deaths, and then we get this rapid growth. So obviously that's a big, huge problem, and we're going to spend, again, some time later on in this week and next week talking about that exact issue. All right, let's try one more. Population of a western town doubles in size every 12 years. So I'm thinking about like the gold boom back in like 1849 and stuff like that. By the way, if you're a football fan, you know why they named the San Francisco 49ers, because in 1849 there was a big gold rush. Everyone moved to California, and San Francisco particularly. So anyway, random. I'm daydreaming here. So anyway, the population of the town doubles in size every 12 years. If the current population is 8,000, so again we're thinking about an old western town, what will the population be 18 years from now or from then? So let's set up our formula. So we got P equals P sub 0 times 2 to the T over D. Let's fill in what we know. All right, we know the doubling time, that's 12 years right there. That's going to be our D number. The current population is 8,000. That's our starting point. Right now we have 8,000 people. We just said a second ago our doubling time was 12. We just need our time. What will the population be 18 years from now? So there's our time, 18 years. So again, I'm going to simplify that a little bit. That's 8,000 times 2, and then 18 divided by 12 is 1.5. So 8,000 times 2 to the 1.5 power. All right, if you go ahead and multiply that out, we would get 22,627.417. Now, that decimal doesn't make sense. What is 0.417 of a person? It doesn't make any sense. It's not logical. So your final answer, which would have to be in words, could be something like the population would be 22,627 if we rounded it or truncated it. And rounding means we use this 4 to round up or down. Truncating means we just throw away all the decimals. So either one works, doesn't matter to me. So make sure you don't have a decimal, though. That wouldn't work. That would make no sense. Again, I don't want to be the 0.417 of a person, and neither do you. All right, that should do it for today. Let me know if you have any troubles or you have any concerns. Good luck.